In this question, it says in triangle PQR, the bisector PQR meets PR at S, and the point T lies on PQ such that ST is parallel to RQ. We need to prove that QT is equal to TS. The diagram is not given in the question. I have drawn the diagram. So let's say that TQS, angle TQS is equal to angle SQR. TQS is equal to angle SQR, as the angle is bisected by the line QS. So before I continue further, let me explain to you the question one more time. In the triangle PQR, the bisector of PQR, the bisector means the straight line should be from this angle, and it's bisecting this angle, and it meets PR, this is PR, at the point S, and the point T lies on PQ. It can be anywhere, but it has given a condition. It lies on PQ such that ST is parallel to RQ. So we need to position the point T in such a point on this line PQ so that ST is parallel to RQ. So this is the possible position where you can mention T. That's how we have drawn the diagram. So coming back to the answer, angle TQS is equal to SQR. TQS is equal to SQR because this is getting bisected. Angle SQR is equal to TSQ. SQR is equal to TSQ. The reason is since TS and QR are parallel lines, that means these are alternate angles. SQR, this angle, and this angle are alternate angles. In triangle TQS, TQS is equal to TSQ. TQS is equal to TSQ. Therefore, the triangle TQS is an isosceles triangle. So why these angles are equal? The reason is if this is getting bisected, that means if this angle is 30, this has to be 30. And if this is 30, this is 30 as well, because they are alternate angles. And from that we can deduce that these two are same. And we know the nature of an isosceles triangle, that is, two of the angles has to be equal and their opposite sides is also equal. Therefore, QT is equal to TS. So the first part has been proved. Now we need to prove that the triangles PTS and PQR are similar. So let's say, let's have a look at the angle PTS. Angle PTS is equal to PQR, the whole thing, this whole angle PQR, because they are corresponding angles. Similarly, PST is equal to PRQ, this angle. This angle and this angle are equal because they are corresponding angles. These two lines TS and QR are parallel, hence these are corresponding angles. Angle TPS is equal to QPR. TPS is equal to QPR. It's the common angle for both of the triangles. Therefore, triangle PTS and PQR are similar. Now for part C, given that PT is 5, TQ is 2, we need to calculate the length of QR. QT is equal to TS. If TS is 2, then if TS is 2 and QT has to be 2 as well, because as I mentioned earlier that QTS is an isosceles triangle and these two sides are equal, and we have also proved this in part A. Therefore, if TQ is 2, TS also has to be 2. Now QR from the bigger triangle divided by TS from the smaller triangle is equal to PQ of the bigger triangle divided by PT of the smaller triangle. And we know the value of all the three except for QR, which we need to find. So QR by 2 is equal to 7 by 5. PQ is 7 because PT plus TQ is 7. So that gives us the value for QR, which is 2.8 centimeter.